Carpe diem VPN. Seize the network.
Hello everyone. I'd like to spend some time today and talk about vManage and the management plane in Cisco SD-WAN with Viptela. The management plane is, as you've probably already guessed, all about managing the SD-WAN fabric. And it's encompassed in a single controller, which is vManage. Now, we're not going to sit here and walk through all the dashboards and screens. That would be tedious and redundant, as we're going to revisit them as we look at the other detailed parts of the solution. So instead, I've pulled together a list of things I believe live in the management plane, and we'll focus on these. Now there's a lot to unpack here, but I think we'll hit each of these from a management perspective, and then talk about them in detail in their own sections. So let's start with Zero Trust Management. I cover Zero Trust in detail in another video, so let's just focus on how vManage is used to manage the relationship. Now here's a list of devices which have been uploaded to vManage. This list is based on the whitelist that you obtained from Cisco that includes devices you've purchased, and it's accessible from the Cisco plug-and-play portal if you have a smart account. Now from the device list, we can change the way we manage the device between CLI and vManage mode. CLI mode is more traditionally of how we think of device configuration management, whereas in vManage mode, we're focused on using template creation and management. Also, in CLI mode, the devices are not locked, meaning that you can make changes locally on the device. In vManage mode, vManage locks the config, so changes can only be pushed by vManage. We can also inspect the configuration applied to the device, change some of the variable values, decommission it, and check some logs if we're having trouble onboarding or applying template changes. Let's move on to certificates. Certificates deserve a much larger section, so we'll just focus on how vManage manages them for now. This is where we manage certificates for the SD-WAN fabric. On the WAN Edges tab, you'll see that the main task we perform is to change the certificate validity for the fabric. There are three settings: valid, staging, and invalid. A valid certificate means that the device is allowed to join the fabric, build data plane tunnels, and forward traffic. Staging means that the certificate is valid for building control connections only. This is usually just a temporary status, while a device is onboarded and awaiting some sort of maintenance window to go into production. In this state, it can contact vManage and vSmart for downloading config and policy, but no data plane tunnels can be formed between this and other WAN edges. It's important to remember that setting a certificate to invalid in vManage in no way invalidates the actual certificate on the device, just its validity to join the fabric. In the invalid state, vBond simply rejects the device from joining the fabric. From here you can also inspect any certificate sign request that was generated as part of the device onboarding. The WAN edges have a device cert installed based on their TPM or SUDI chip. Virtual devices have a token generated and can be onboarded if they have that token configured. For the controllers, there's a lot more we do here. Because the controllers are not onboarded to vManage automatically the way WAN edges are, there's no whitelist. We have to manage a lot more of the certificate enrollment process manually. Now, I'm not going to cover onboarding in this video, but part of the process involves the vManage generating a certificate signing request for the controller and then installing the signed certificate once it's signed. You'll notice we have a lot more control over what we do with the CSRs and the certificates in general. We can generate a new CSR, we can invalidate it, and we can see the installed certificate once we've installed it. I should note that if you elect to use cloud controllers managed by Cisco CloudOps, all of this part is managed for you. Let's spend just a brief minute to look at the settings on vManage for managing certificates in general, especially the vManage's own certificate. You see we can actually control what vManage uses to do the certificate authentication for both the WAN edges and controllers. In the case of WAN edges, we can do it via Enterprise CA or just use the on-box certificate or the token if it's virtual. For controllers, we can automate the cert enrollment either via the well-known CA Symantec do it manually, or use an enterprise root CA. The Cisco automated option is a new option and can just use the installed Cisco certs automatically. Notice that if you do elect to use an enterprise root certificate, you have to get one signed and installed for vManage so that vManage can generate the CSRs for the onboarding controllers. Last is the web certificate. This cert has nothing to do with the SD-WAN fabric, it's just for trusted browser access to the vManage web GUI. Device code upgrades and templates is something we'll cover more in detail at another time. They have their own sections on the exam blueprint, but I wanted to at least talk about them in terms of how vManage is used. We definitely need to spend time talking about how control connections are used and how vManage delivers configuration though, so we'll cover that in detail. The software repository is generally where we put software upgrade files to be pushed out via vManage. You can see how we have the option to either use vManage itself as the repository or specify a remote server to pull from. When you add an image to the software repository, vManage will check its validity as an SD-WAN software image and determine for what fabric components it can be installed. We can choose to upload the files directly to the vManage, target an FTP HTTP server to download it from, or even another remote vManage that already has the image we're looking for. Let's look at software upgrades. Managing the software lifecycle is pretty simple via vManage. We can upgrade the controller infrastructure, including vManage itself, and of course the WAN edges. Now, software management has its own section on the exam blueprint, so we'll cover that more in detail in another video focused specifically on the software lifecycle. But I just want to make you aware that vManage and the management plane is where we do the software upgrade process. Next, let's look at device templates. Templates are how we control device configurations in the SD-WAN solution. They are created in vManage and then push to the devices programmatically. Templates are definitely important enough to need their own videos, so in this one I'll just touch on how we provision them using the management plane with vManage. There are two major types of templates, CLI templates and feature templates. Both template types must be associated with a device template. The major difference between the two is how the device configurations are dealt with by vManage. CLI templates are entire configurations which become a device template, whereas feature templates are modular pieces of configuration that are then attached to device templates, similar to building blocks. Let's take a look at a feature template now. Feature templates support multiple device models. Because of this, we can reuse feature templates across device templates more globally. But it's important that these overlapping models support similar features. You can see in this case, this template applies to only a single device type, which is the vEdge Cloud. The feature templates are plug and play, which means they're managed as individual objects with options rather than a simple command line list. Each feature template covers some particular topic, like this one is for BGP, and it's the combination of the feature templates which are used to build a device template. Let's take a look at that. So here we have a device template for the branch CSRs. Let's open that up and take a look at how the feature templates are rolled up to create the device template. You can see here where we've got multiple feature templates that have been created and then attached to this particular device template. Putting it all together creates the business intent for that device type. So in this case, the business intent is for CSR that has multiple transport connections, a single service VPN, and this will serve as the branch template for all of our branches. Here we'll just bring up a device template. We'll make some basic small change and we'll push it. Because this is a feature template and it's using variables, I can use change device values to edit some of the device variables and make changes if I want. Let's see something fairly non-impactful I can change and push to show you how this looks like. So you can see here, all based on the feature templates which we have attached to the device template and the variables within those feature templates, that we have some options here, some things that we need to change that make it specific to the device for the specific deployment. So let's change something fairly non-impactful. Let's change the host name. Just change it to, say, branch 1 WAN 10, something simple. We'll go ahead and update it. And you can also see here that because the device template is shared by multiple devices, we have the opportunity to change variables on multiple devices. In this case, we're just going to push the single change, so I'll just click Next. And then looking here, we have the ability to inspect the devices that will be that share this feature template, or rather this device template, and what changes we pushed. We made only a change on branch 1 WAN 1, so let's take a look and see what changes will be pushed here. So here you can see the actual config that will be pushed as part of the feature template push. I think since we changed the host name, it'll be up here. So you can see that will be our change, and we can even go to config diff and see the change we're making. So the major changes right here, you can see that we're changing the host name. The personality isn't actually going to change. I'm not sure why it shows that. The personality is just the type of device it is. It was already a CSR, so I'm not sure why it's showing that. We can look at the side-by-side differences as well. So it's pretty robust. It gives us a really good way to check and see the changes that we're pushing before we push them. One more thing I want to bring attention to is that the device does have a rollback timer. So what that means is that if we end up pushing a change that causes the WAN edge to lose connectivity to the vManage, there's a countdown, and after this countdown, the config push will be rolled back to the previous prior good config, and the WAN edge should reconnect to the vManage. Let's go ahead and push this configuration change and see what happens. So vManage warns you if you're going to affect more than one device. Again, in this case, we're not really affecting more than one device because we only made one template change for the WAN 1 router, but it lets us know that we're going to make changes on multiple devices. So we'll go ahead and click OK, and what should happen next is the template change should be kind of formatted programmatically and then delivered via netconf to the device. So I'll pause here, and as soon as it gets pushed, we'll bring it back up. Alright, looks like we're pushing our changes now. Just took a second. So let's go ahead, we can actually look at the status of this. So let's see, we push the change to branch 1, WAN 1. Let's take a look. You can see the actual logging of the template changes we're making. And if we give it just a minute, we should see that it was delivered. Alright, looks like we pushed the template change. Template successfully attached to device. And that's all there is to it. We should be able to go to that device now and actually see that the hostname has changed. Okay. Hostname BR1 WAN 10. So that's all there is to it as far as pushing template changes. If BR1 WAN 1 had been a CLI template, we would have had to edit the configuration in the CLI template and push the entire config again. It still would have been delivered programmatically. It's delivered via netconf. So that's all there is to that. Speaking of, now we need to talk about control connections and how configs are delivered from vManage. So let's do that now. Here we are logged into branch 1 WAN 10 for the moment, and we're just going to take a look at the control connections. Remember that control connections are DTLS encrypted connections between the WAN edges and the vManage vSmarts, and when it's onboarding, the vBond. So it's not like an IPsec dated plane tunnel. It's just a DTLS encrypted tunnel, where we're going to send all of the control connections over. So taking a look here, we can see that our WAN router has multiple colors, meaning multiple transports. One is biz internet, one is public internet, and that we've created multiple connections across those colors, one using each color to each vSmart. So for example, we have two vSmarts, and we've built two control connections to each vSmart, one over each color. Notice, however, that the vManage only has one connection. It's built over biz internet. This is by design. The WAN edge will only build one control connection to the vManage over one of its colors. If that color drops, the vManage connection will momentarily drop while the WAN edge tries to rebuild the connection to vManage over the other color, or any number of other colors that you have. But at most, we'll only ever have one control connection up. So that's basically how the control connection works between our infrastructure and vManage. It's the same DTLS tunnel that we've covered in my Zero Trust SD-WAN video. So now that we've done that and looked at that, let's go ahead and take a look at how it looks when we push template changes through vManage, what the config delivery model looks like. Here we are logged into vManage, and we need to use the vManage CLI because this is basically the only way to tell how the templates actually get pushed. Those templates are encrypted in DTLS tunnels between the vManage and the WAN edge, so we can't simply do a packet capture and inspect the packet to see what's being delivered. And of course, that's by design. So we can do it from vManage though. We just need to drop down to the Linux shell, so we'll do that now with vshell. And then from here, we just need to look at the logging. So we'll go to var log/nms, and looking, we see several logs that should give us some good insight into the template delivery. So we're going to go ahead and do a tail on which just looks at the last few lines of a file, and we'll do it on vManage server. Let's see, device, and we'll do config and see what we have here. So here you can see we're getting some details about how the templates are being pushed, so this is what we need to look at. So now we'll do a tail-f, and what that will do is keep the file open and showing on the CLI here, and then we're going to go ahead and push the config change and fix the name of the WAN edge back to normal, and that should populate this and show us the template that's being delivered. So let's do that. So go ahead and log back in to our workstation. You can see I've already got the device template up here. We're going to change the host name from 10 back to 1, and we'll click update. And of course we'll go to next and push the config. We can check to make sure the config is correct, but I'm pretty sure it is. So we'll just go ahead and start configuring the device and start pushing this template. And now I'll minimize this, and we should start seeing, oh yeah, quite a bit of data here as vManage creates and then pushes the config down to the device. So we'll just wait for that to be done, and then we'll look at the scroll back and see kind of what's going on here. Let's check and see if this configured complete. Yep, looks like we're done. So we can go ahead and stop the open log, and now we can take a look at the we just take a look at what changed. So let's scroll back as far as we can here, start taking a look at this config push. So there's quite a bit, as you can see. I'm not even sure if we go back far enough here. Okay, so it looks like how this works, as you can see, is first vManage creates a device personality, sets up a device dummy model. This allows vManage to kind of populate a dummy template so that it can then deliver it to the device. So it creates the dummy template and then it loads it, and then over a series of transactions here, we start delivering it. You can see that we're using this programmatically. You can see the way that we're delivering this config. And so it goes through an iterative process through the template and delivers it programmatically. And then there's going to be a little bit extra at the bottom because we're running security features and we're using a Linux container. But the main thing I want to bring attention to is how we're actually delivering the configuration to the device here. So you can see we're using netconf to deliver the config, although the config itself is in XML format, as you can see here. See if we can scroll up a little bit and show it. You can see it here, loading configuration in XML format. So now that we've covered control connections and how delivery of config happens, and indeed what the config looks like as it's being delivered, I think that finishes off this section. Now we still have plenty to look at, of course. Let's go back and take a look at how far we've gotten. Let's see. So we covered Zero Trust Management, and we covered Device Management. Wow, it took a while. We still have to cover a little bit about Fabric Management, how we get telemetry, and then just a high level of how we would do troubleshooting, and then finally access control. We'll cover that in the next video. Thanks for watching.